Hi, welcome to the video solution for Edexcel IAL Mathematics. This is M1 for new specification sample assessment material for 2018 specification. So let's start. Question number 1. Initially they gave you some information that for value of G you are going to use the value 9.8 and you need to give answer either in 2SF or 3SF. Question number 1. A car is moving along a straight horizontal road with constant acceleration a meter per second square. At time t equal to 0, the car passes a point P moving with a speed u, and in next 4 seconds it travels 76 meter, and then following 6 seconds it travels 219 meter. Find the value of u and a. So the situation is, if you see you have a car traveling on a straight road, so at t equal to 0, this is the point P where you find some car traveling with the velocity u and has an acceleration of a meter per second square. So after 4 seconds the car travels till, let's suppose, the point A, and this distance is 76 meter, and the car keeps moving with the same acceleration, and following 6 seconds it reaches at point B, and from A to B it travels further 219. So this distance is from A to B is 219 meter. We need to use these information to figure out value of u and a in both of the parts. If you see the situation, we have two unknown to be found, and that means we need two equation. We have three intervals from P to A, from A to B, and from P to B. So the interval A to B is not useful. The reason is because we don't have velocity at point A, because A and U are unknown. So for the meantime we cannot use the interval A to B. So first of all I am going to use the interval 1 from P to A. So from interval P to A, I can say that S is equal to ut plus half at squared, and S in this interval is 76, and then is equal to u is u, and time is 4 seconds, plus half of a into t square, which is 16. So 76 is equal to 4u plus 8a, and then you can take 2 common from this equation to make it simplified. So it will be 38 is equal to 2u plus 4a. This is your equation number 1. And now I'm going to use the information for interval P to B, the whole interval. So for this whole interval I'm going to use same equation, S equal to ut plus half at squared. So for the whole interval the total distance is 295 is equal to ut, and the total time is 10 seconds, plus half 80 square, that means it is 100, and then you can cancel, it is 50. So 50 and this is 10, this is 295, so you can take 5 common, and if you take 5 common after simplification you have 59 2u plus 10 yes 10a. This is your equation number 2. For part 1 we need to find u. That means we need to get rid of a from these two equations. The idea is you can use elimination method or substitution method, whichever suits you. You need to solve these two simultaneously to find out value of u. And what I'm doing here, I'm thinking to get rid of a first. The coefficient of a is 10 in the equation number 2, and the coefficient of a in 1 is 4. So I'm going to multiply this whole equation by 4 so that I have a 40a here, and then I'm going to multiply equation 1, the whole equation 1, by 10. So the 10 times 4 will be 40a. So 40a and 40a will be there. Then I'm going to subtract these equations. So if I multiply these equations, then after multiplying the first equation, I have 380 is equal to 20u plus 40a. And then after multiplying by 4, I have 236 is equal to 8u and plus 40a. So I need to subtract. Subtraction mean need to change the sign of any one of the equations. So minus, minus, and then minus. So you can subtract these two. So your answer would be equal to 12u 380 minus 236. So you have 144 here, and 40a cancel, and it will be 20 minus 8, which is 12u. Finally, u would be equal to 12 meter second inverse. This is your answer for part 1. And find the value of a. You just substitute this value of u that you found here in any one of the equation, either in equation 1 or in equation 2, to figure out value of a. If you substitute a, then a would be equal to 3.5 ms minus 2. That's how you can figure out answer for second part. Question number 2. Two particles P and Q are moving in opposite direction along the same horizontal straight line. Particle P has a mass m and the particle Q has mass km. The particles collide directly. Immediately before collision, the speed of P is u and the speed of Q is 2u. As a result of the collision, the direction of motion of each particle is reversed and the speed of each particle is halved. Find the value of k. So it's again a straightforward condition for law of conservation of momentum, but you can see the situation like you have two particles. This is the particle P of mass m moving in that direction, and another particle, so this is particle P, another particle Q with mass km moving in opposite direction, and then they collide, something like that. They collide here, and then after collision they separate and moves in opposite direction. So the initial velocity of particle P before collision is u. So this is u and this is 2u. And after collision, the speed of each particle is halved. That means it will be u by 2 and it will be u for particle Q. So now you know that this is the law of conservation of momentum. So according to law of conservation of momentum, total momentum before is equal to total momentum after. But whenever you apply law of conservation of momentum, you need to take care of the direction of the motion, because momentum is a vector quantity. And it's your choice whether you take rightward direction as positive. If you do that, then the leftward direction will be negative for you. That means rightward motion will be positive, so momentum will be positive. The leftward motion negative, so momentum will be negative. And you can use vice versa, it's up to you. So I am using rightward as positive, leftward as negative. That means the momentum for particle P before collision, mu, is positive, and momentum of particle Q, which is leftward, and the momentum will be 2k mu, it is negative. So I'm applying momentum before collision. So law of conservation of momentum. So momentum before collision for particle P, I can say that this is mu, and the minus momentum of particle Q before collision, it is 2k mu, is equal to momentum after collision, total momentum after collision. So momentum of particle P after collision is minus half of mu and plus momentum of particle Q after collision, which is K M U, and you can cancel M easily here. So finally you have equation, and also you can cancel U's here, I guess. Yes, U, this U and this U is gone. So if you see the situation, you have 1 minus 2k is equal to minus half plus k, and then you can rearrange for k, so k would be equal to half, because 2k plus 3k half, 3 by 2, yes, it is fine. So you can find k is half. This is the value of k. Part B, find in terms of m and u only the magnitude of impulse exerted on q by p. So you need to find impulse exerted on q. So impulse exerted on q, IQ, is change in momentum of the particle q. So you can say that the change in momentum of particle q is so final momentum, which is kmu, minus initial momentum, and initial momentum is minus 2kmu, 2kmu. And if you simplify this, you have so it is 3 kmu. This is impulse on q. But if you read the question, they are saying find in terms of m and u only. That means you need to get rid of this k, meaning just substitute the value of k. So IQ, impulse on q, would be equal to 3 by 2 mu. This is the impulse on q. Question number 3. A block A of mass 9 kg is released from rest from a point P, which is a height h meters above the horizontal soft ground. The block falls and strikes another block B of mass 1.5 kg, which is on the ground vertically below P. The speed of A immediately before it strikes B is 7. The blocks are modeled as particles. Find the value of h. So the situation is, you have a ground, and you can think this is the ground, and on the ground you have a block B here, and the ground is soft, remember, and you drop a block A from some height. This is the height, and it is falling down. So when the block just hit, at that moment the block has velocity 7 meter per second, and we need to figure out h. So again we have a condition of free fall motion, so we can use this information to find the height. And how do you do that? You can use the equation v square is equal to u square plus 2as. S is the height or the distance traveled. So you can substitute the value. You can, v is the final velocity at the time of impact. So this is 7 squared is equal to u is initial velocity, because the block is dropped. That means initial velocity is 0, plus 2 into 9.8 into s you can replace with h. So if you simplify this and then solve for h, so h would be equal to 2.5 meter. This is the height from which the block A is dropped. Immediately after the impact, the block B moves downward together with the same speed, and both comes to rest after sinking a vertical distance of 12 centimeter into the ground. Assuming that the resistance offered by the ground has a constant magnitude R newtons, so find the value of R. Now what happens here, if you see the situation, after impact both the block becomes as particle 1, and then they both sink into the ground together, keep sinking, and then suppose till here, and that distance they sink till 12 centimeter. And during that sinking, so if you see the situation what is going on, suppose this is the block, these are the two blocks considering as one. When it is falling down or sinking in the ground, the block is experiencing two forces. The number one force is weight acting down and the constant resistance force R, and we need to figure out this R as per the requirement. But the particle is sinking down, that means it has some acceleration because initial velocity was something else, but final velocity is 0, so velocity is changing. That means during the sinking process the block is experiencing some acceleration, and this acceleration cannot be 9.8. remember, it is something else. So we need to figure out the acceleration, and that means the particle also has some resultant force. So that concept we are going to use. So first of all, we need to figure out the velocity when both of the block after impact they start sinking. That means initial velocity after impact, and we are going to use law of conservation of momentum before impact here and after impact. So before impact only particle A is falling or moving, so we have momentum of particle A only. So mass of the particle A is 9 and velocity is 7 before impact, is equal to after impact both the particles are moving as one together. So we can say that the total mass is 1.5 plus 9, it is 10.5 times the velocity just after impact. And now this is just use the velocity just after impact and after which it starts sinking. This u you can find after simplifying, and u is equal to 6 meters per second. And now you can use this fact. Initial velocity is 6, the final velocity is 0, because you say that after covering 12 centimeter they both come to rest, and the travel distance of 12 centimeter. We use the same equation to figure out acceleration here. So you can say that the final velocity is 0, the initial velocity is 6 squared plus 2 into A need to be found, and S is the distance or the height during sinking process. It is 0.12. You can use this equation to figure out A. Then A would be equal to minus 150 meter second minus 2. This is the acceleration. And now what is happening as it is sinking down, so the blocks are experiencing a downward resultant force F, or you can say this is MA. So now you can write this equation as W minus R is equal to the resultant force F. So W is weight, which is 10.5, the total mass of both of the blocks, times G 9.8, minus R you need to find, and F is MA. So MA is 10.5 times A. A is minus 150. And then you can solve this equation for R. So R would be equal to 1677.9 Newton, or you round it off, so R is equal to 1680 Newton. This is the constant resistance force. Question number 4. A diving board AB consists of a wooden plank of length 4 meter and mass 30 kg. The plank is held at rest in a horizontal position by two supports at point A and C, where AC is 0.6 as shown in the figure. The force on the plank A acts vertically down and the force at C is vertically acting upward. A diver of mass 50 kg is standing on the board at B. Diver is modeled as a particle. The plank is modeled as a uniform rod. In equilibrium, find the magnitude of force acting on A. Okay, so this is again a typical question of moment. First of all, you need to see the situation and you need to figure out how many forces are acting. So the diver is standing at B here. So first of all, the first force acting is weight of the plank, and it is uniform. It is acting at the center. So mass of the plank is 30 kg. So weight is acting downward at the center, like that. This is 30 g. And the diver has a mass of 50 kg standing, so here we have a 50 g. And again you can see we have upward force here and we have a downward force at A, and we need to find this downward force. So let's call it FA, force at A, and force at C, FC. In the first part we need to find FA. So we take moment about C, because if we take moment about C, that means C as a pivot, that means there will be no moment causing by FC. So FC is gone in the calculation. FC cannot produce moment, it is acting at the pivot. So you can say that moment about C. So because C is pivot, so you need to figure out how many clockwise and anti-clockwise. So this is your pivot. So the force FA is going to produce moment in anti-clockwise moment, while 30G and 50G are going to produce moment clockwise. So these two are clockwise moment and this one is anti-clockwise moment. The only thing is you need to figure out the distance of weight of the plank and distance of that person. You need these two distances for the moment, and you have a 4 meter length and you have a 0.6. So easily this you know that this is uniform, so you can say that this distance would be equal to 2 meter. You can use this information and you can say that the moment about C. So about C you have only one anti-clockwise moment due to FA. So you can say that FA times 0.6 meter. This is moment anti-clock equal to clockwise moment, and clockwise moment will be 30 times 2 minus 0.6, which is 1.4, plus moment due to 50. So 50 times 3.4. And now you can see that you have only FA unknown in this equation. You just multiply and add and then divide by 0.6. So you have FA as 62.6 Newton. 3462.6 Newton. Part B, the magnitude of the force acting on the plank at C. So now you need to find FC. So take moment about A. And now if you take moment about A, so you can think that A as a pivot. If A is a pivot, then FC is going to produce moment. 30G and 50G are going to produce clockwise moment, and Fc is going to produce anti-clockwise moment. So you can apply for moment equation. So for Fc, you have Fc multiplied by 0.6 is equal to 30 times G into 2. Oh, I'm sorry about the previous part. I forgot to use G here, please. I'm sorry about that, because this is force. It should be G here. And then when you do your calculation, then you have this number. It should be force, not the mass, because 30 is a mass, but force is 30 G. So don't forget to use G here. So now come back to the next part. So Fc is 0.6 is equal to 30 G times 2 plus 50 G into 4. So again, you can find 50G and 30G times 2 and times 4, then add and divide by 0.6. So Fc would be equal to 4246.6 Newton. The support at A will break if subjected to a force whose magnitude is greater than 5000 Newton. Find in kg the greatest integer mass of a diver who can stand on board at B without breaking the support at C. So if you see the diagram, they are saying here the maximum force that A can bear before breaking is 5000 Newton. So you need to find the maximum mass of the diver here that can stand without breaking the plank. So let's suppose the mass of the diver is now m. That's what you need to find. So the weight acting for the diver is downward, which is mg. Again, we have a 30g here and Fc. This is Fc. But Fc will not be the same as before because we have changed Fa. But we need to find m. So we don't need to worry about this Fc because we need to find m, and force on A is given, so we can take C again as a pivot. So the moment about C would be equal to, so you see how many clockwise and anti-clockwise. This is your pivot, so you can think that the A or the 5000 is going to produce anti-clockwise moment, again to clockwise moment. So for anti-clockwise moment we have 5000 times 0.6 is equal to clockwise moment, so 30g times for that we need that distance. It is 1.4, so times 1.4 plus mg times 3.4. Clearly there is only one unknown left, which is m. You can solve this equation for m after multiplying and addition. So you have m is equal to 77.7 kg. Part C, explain how you have used the fact that the diver is modeled as a particle. Typical question, assumption about the how did you assume. So weight is acting at a point. So weight is acting at a point. This is our assumption for a particle. Thank you very much and have a nice time.